we're going to review greatest common factor, so you are not confused. Are you ready? Okay, I'm going to give you one, so you're going to do it. So the first one is, that was the first one. The next one is 81 over 108. Okay, so let's do it. 81 over 108. Okay. When you see this one, what's number comes out, just popping out off the page to you? What number are you thinking of? When you see 81, what number are you thinking of? Yeah, is it a 9? Good. Okay. So tell me, how can we break apart these numbers? So we are using the greatest common factor to cancel it out and make this really easy. Okay, so 81 is 9 times 9. 108 is 9 times, that's right, 12. Are you seeing that? So what's our greatest common factor? It's 9. Actually, no, it's not. Okay. So that cancels out, but look at this. Can we still break apart those? Yes, we can. So 9 is 3 times 3. What is 12? 3 times 4. So sometimes you may not know what the GCF is because you just haven't memorized the multiplication table up to 24. And that's okay, and that's when this is going to happen. Okay, so you just keep going. So 3 over 3 is going to cancel. We are left with something we can't break apart, which is 3/4. So my question to you is, what is the greatest common factor? What is the greatest common factor? It has to do with 9 and it has to do with 3. What do you think it is? You actually multiply the 9 and the 3 together to get 27. The greatest common factor is 27 because 27 times 3 is 81. 27 times 4 is 108. But as I said, you may not know the multiplication tables, and that's okay. So break it down, and if you find you can still break it, keep doing this process. And then what you'll do is you'll take the GCF you thought was the GCF and each one, multiply it together to get the true GCF. All right, put a smile on your face if that's making sense. Yay. No, not at all? Okay, let's do more. So what about this problem? Let's make it a little bit smaller. 18 over 27. How would you break that apart? 18 over 27. Okay, break the top and break the bottom. And do this in as few of steps as possible. Okay, I'll give you about 8 more seconds. Okay, so 18, that can go a lot of different ways, right? 1 and 18, 2 and 9, 3 and 6, okay? And I think that's about it. But look at the one on the bottom. This one is 3 times 9, or 1 times 27. So we're kind of limited there. This is 1 times 18, which we don't even need to write down because it's not useful. So what do you think? Which one do you want to use? Okay, I'm thinking this one. What do you think about that? Let's try it. 2 times 9, 3 times 9. What cancels out? Not the 2/3. This guy. Same thing, top and bottom. If these were plus signs, somebody's asking, if these were plus signs, you couldn't do this. Only if it's multiplication or division can you cancel things out. Because what it's really saying is 2/3 times 9 over 9. 9 over 9 is 1. So what you're left with is 2/3. Okay, how are you feeling about this one? Good? Okay, I've got 2 more for you. Can you do both of these? 35 over 50 and 100 over 150. Okay, ready, set, go. Okay, so ask me questions if you have them. Somebody says I'm not good at math. I wasn't either. I was terrible at bike riding until I learned. And I was horrible at swimming until I practiced. So yeah, happens to everybody. So this is your practice. Go for it. Okay, so what do you see with these two? Are you seeing a 5? Good. 5 times something is 35, and 5 times something is 50. You want to do the bottom one? Is that one easier? 5 times 10, excellent. And 5 times something gives me 35. Who knows what it is? Yeah, I see you guys shouting at me. Perfect. Okay, so 5 over 5 cancels. We have 7 over 10, which is as small as you can go. All right, what about this one? What about that one? So this is 10 times 10. This is 10 times 15. Okay, imagine that's how I saw it. Am I done? Can I just say, here, Aurora, here's the answer. That's it. No, I would say, well, you could do that a little bit more. 10 is 2 times 5. 15 is what? What times 5? Yeah, that's right, 3. Good, so we'll cancel those out, and this guy actually goes all the way down to 2/3. Doesn't look like it though, does it? Excellent, excellent. Okay, extra credit. Who can do this one? You can do either the top or the bottom, your choice. Ready, set, go. Okay, you can do one or the other. Which one would you like? Okay, so we're going to break apart the top and the bottom, top and the bottom. How would you break apart the 44? Yeah, what do you think about that one? 44 is 11 times somebody. Yeah, it's 4. Excellent. Good. How about the 28? Is the 28 anything times 4 that you recognize? You recognize anything there? Yeah, what is it? How about one of those? Excellent. The 4 over 4 goes away. That goes away to 1. Not 0. Goes away to 1. 7 over 11. Good. And how do you feel about this one? We have 4 times, I'm just going to guess, 4 times 8 and 4 times 12. Oh, did I get it, or do I have to do more? No, I got to do more, don't I? Yeah, don't let me get away with it. Let's see. The 4 goes away. But then what do I do with the 8 over 12? I could throw it out the window, I suppose. How about we solve it, though? 2 times 4. Good. And 12 is 3 times 4. See, it's like a puzzle. You just keep working at it, keep chipping away at it until you get an answer that you're happy with. Good. Okay, how are you feeling for the review? Okay, if you need more practice, that's what your workbook is going to do for you this week. So make sure you keep up with the assignments and just take your time with this. You can rewatch the recording after class today and make it go slower, pause me, see if you can beat me to the answer afterwards. So if you need a little bit more practice with this, just know that you can do that. Okay, you ready? All right, so where are my kids that are enjoying cookies? Who is a cookie enjoyer? Is that even a thing? Yeah, okay, great. All right, I have 30 plates, and we baked 60 cookies. Do it in your head. 30 plates to fill, right? We got 30 kids in class. Every kid gets a plate, and we baked 60 cookies. How many cookies goes on a plate? Oh, you can totally do this in your head. How many cookies per plate? A half? Are you sure? Okay, let's write it down. I have a plate. I have 30 cookies. I'm sorry, I have 30 plates. 60 cookies. Which one's more? Which number is bigger? Yeah, the 60. Okay, so here's a plate. And I am going to make it even. So every plate has, so I'm going to put 60 cookies on 30 plates. See, I can put words in fractions also. 60 over 30. How many times does 30 go into 60? 30 twice. So this is 2 cookies per plate. So we just did the division here, and we kept the units. 2 cookies per plate. So 1, 2, there they are. Okay, good. We have, how many of you have a marble collection? I still do. I have my original marble collection from like the 1980s, and it's in a tiny little Pac-Man bag. Okay, so imagine we've got some marbles, and 25 are shooters. Do you know what those are? Are shooters the little ones or the big ones? Well, not this big. Can you imagine a marble that big? All right. They're 1 inch in diameter, usually. Okay, so shooters, we have 25 shooters and 75 marbles. And I want to make some packets for kids. Okay, so how many packets can we make? I have 25 shooters, 75 marbles. I want 1 shooter in every packet and then just marbles. Okay, so how many in each packet? Let's see. Okay, so I have, my collection has 25 of the large marbles. Those are called shooters. And 75 of the regular sized marbles. Okay, and I want to make a pack and give them away to you guys. And every bag has to have at least 1 of the big ones. So, yep, I have 100 marbles total, but for this right here, is that a useful piece of information? Okay, not quite, because look at what we're doing. I have 25 shooters, 75 marbles, so 25 to 75, okay? How many 25s are in a 75? If I put 1 in here, this determines how many bags I'm going to have, because every bag is going to have 1 shooter, 1 big marble, okay? And if that's the case, and I'm going to put little marbles in there, I have 25, so I have 25 bags, so I can actually flip this. 75 marbles in 25 bags. Okay. How many times does 25 go into 75? Yeah, I see it now. 25, 50, 75, if we're counting by 75. So 3, so 75 is 3 times 25. Okay, in case you didn't know that. So that means that we can have in the numerator 3 times 25, and in the bottom is 1 times 25. So the 25s are going to cancel. So that tells me we have 3 marbles per bag. So we're going to put 1, 2, 3, and that will use up everything we have. You would like a bag of these? Aw, good. Okay, good job. So we made 25 packets. Exactly. What happens if the numbers aren't so nice, right? Because when we first start math, we give you really nice numbers, so it's not so scary, and also so you don't get lost. Okay, but what if it's not so nice? Imagine a farmer, so write this down on your paper, has 75 carrots and 90 potatoes. 75 carrots and 90 potatoes. Okay, so what they want to know is how many vegetables go into a basket, so all the baskets are the same, and it uses all he's got. So how do you do that? Okay, so let's go down and get ourselves a fresh sheet of paper. 75 carrots and 90 potatoes. Okay, so what we need to do is we need to find the greatest common factor. Okay, and we want to put them all in a whole bunch of baskets, so the baskets are all identical. They all have the same number of potatoes and carrots in each one. But they don't go in evenly like the cookies and the marble example that I just gave you. Okay, so what we do is we break apart these numbers. Okay, so let's break them apart down here. 75, what do you see when you see a 75? We just had it on the other page at the bottom. Look, right there. You see that? So 3 times 25. Okay, let's break it apart more. Can you break that 25 apart? What do you get? Yeah, 5 times a 5. Good. Okay, so you can write that down. Let's write down the 90 potatoes. So here's a 90. Let's break it apart. What does it look like originally? If you think about tens, what does this look like? Yep, 9 times 10. Can I break apart both of these or just one of them? Yeah, both, right? What's the 9 turn into? Make it as small as you can. Break the whole thing down. 9 is 3 times 3. 10 is 2 times 5. So 3 times 3, this is the 9. Here, I'll put it here. 3 times 3. And this one is 2 times 5. Okay? So this is the 10. This is the 9. Give me a smile if we're good so far. I didn't lose anybody. We're good? Okay. So what do you do now? So now I see who's common in both lines. There's a 3 here and a 3 here. There's a 5 here and a 5 here. There's a 5 here and nobody. There's a 3 and nothing. Nope. Okay. So what we do is we multiply those two together. So whatever factors are common, so you break it all the way down as far as you can. And then whichever factors are in the same as in both numbers, you just multiply them together. 3 times 5 is 15. So your GCF is 15. Okay. A lot of us don't know our 15 times tables, and that's okay. So this is how you would do it. So then 15 times something gives you 75. So to save time, I'll just tell you it's 5 times 15. Because 4 times 15 is 60. That's easy. Add 15 more and you get 75. Okay. 90 is 15 times 6. Okay, so you take that 75, add another 15, you get 90. Okay, now what does that tell us? That tells us there are 15 baskets. So whatever your GCF is, that's how many baskets we have. And in every basket, you're going to have, so the 5 was the carrots, and the 75 was the carrots, and the 90 was potatoes, right? So there are 15 baskets, and with 5 carrots and 6 potatoes. And there are 15 baskets. And that's how you can interpret the math. Okay, let me pause there. Okay, ask me your questions. Ask me your questions. No questions, you guys have completely got it. You can teach class from here on out. That would be so cool. I would love it if you guys taught class. It has been so long since I've been in, well, I'm actually taking a class right now, but it's so long since I've had a math class. That would be so cool. Okay, you would like another example. Okay, I have 2 more examples. Which one do you want? Do you want the gardener one or do you want the baking the cookies one? Can you put it in the chat? Which one? We'll do one more that has it like this one. Like this one. So we got cookies or we have flowers. You really can't go wrong with either one. All right, lots of cookies. Okay, all right, so we're baking cookies. And you know, when we bake cookies, what happens? We munch on them. Some of them break. Some of them are around the rim, so they get burnt, right? So you don't have always the right same number, right? So the number that you intend. So yes, so make sure you're only submitting something once in the chat. Otherwise, you clog it up, and I can't see other people's questions and responses. All right, so here we go. We're going to do some baking. You ready? Let's do some baking. So